Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. I wish to all. My name is Nasri bin Semyon and I'm going to be your moderators for today's webinar. I'm from the Assistant Vice Chancellor Office, Industry and Community Network, University Technical Malaysia Melaka, UTEP. First of all, I would like to take this opportunity to wish all our Muslim participants Selamat Hari Raya Maaf Zahir dan Batin. May you enjoy your festival with happiness, warmth, and joy together with your family, relatives, and friends. For your information, this webinar series is under the Knowledge Transfer Program. It is one of the Ministry of Higher Education methods to transfer knowledge from the university to the industry. Q&A session will be held after the presentation. At the end of this webinar, the audience will receive a link to a feedback form. The audience who fill up the form will receive a digital certificate of participation, and those who from UTEM will given CPD points. Today's topic is a very interesting topic, which is CAD, CAM, and Advanced Machining Integrated System in Aerospace and Automotive Motorsport industry, and will be delivered by technologist Sharul Azmain bin Sudin alias Swandi. Sundi alias Swandi. Okay? So before we start, I would like to introduce and read a little bit about our speaker today. The speaker has extensive experience in preparing CAD, CAM programs utilizing the CATIA V5 platform and machining aerostructure parts of the giants in aerospace industry such as Boeing and Airbus. In addition, he has successfully gone through comprehensive training and advanced machining of aerostructural components in Gifu Prefecture, Japan. Upon coming back to Malaysia, he served one of the biggest Boeing metallic machining vendors, IME Aero Manufacturing, ISC Sendirian Berhad. At the same time, he also assists a few local companies with machining jobs, namely Impressive Age Group Sendirian Berhad, Ilmek Precision Engineering Sendirian Berhad, Hemser Aerospace Sendirian Berhad, TTRM Composite Malaysia, and many more. On the other hand, the trainer also had experience working in several machining companies in the United Kingdom, preparing CAD, CAM programs for aerospace industry, such as Aerofighter, as well as for the big names in motorsport industry, namely Aston Martin and Ford Racing Team. Recently, the speaker has assisted Nadi Aero Consultants Sendirian Berhad to deliver machining project for UMW Aerospace and SME Aerospace. The speaker just completed his PhD in the machining of aerostructure composite material, focusing on the cutting tool geometrical design. Congratulations, doctor. The speaker also a registered chart engineer, Institute of Mechanical Engineer, UK, Professional Technologies, Malaysian Board of Technology Board, and graduate member of Board of Engineer Malaysia and Institute of Engineer Malaysia. Once again, congratulations. Without further ado, I would like to invite technologist Sharul to deliver his speech. Mr. Sharul, the floor is yours.
Right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good afternoon. Thank you so much, Mr. Chairperson, Mr. Nasri, for the brief introduction on myself, and of course to my fellow colleagues. Welcome to the session, to the next session. I think this is the series 10 of the KTP Knowledge Transfer Program. So it's my turn. So I guess for this afternoon, I would like to share a little bit, probably some experience that I have gained throughout my experience in UTEM as well as in other industries out there. So probably this kind of experience and just a little bit of experience that I can share will actually inspire probably some of us to collaborate with the industries out there, hopefully, yeah. So without further ado, please allow me to share my screen, my PowerPoint. All right, so is everyone able to see or able to view my presentation? Right. All right, thank you. All right, thanks for the feedback. All right, just a brief one. So the topic that I'm going to share for today or this, thank you, Prof. This afternoon is entitled CADCAM, an advanced machining integrated system in aerospace and automotive motorsport industries. So basically just a little bit sharing from me myself on what is the CADCAM and what is the advanced machining situation out there in the current industry. So hopefully every one of you will enjoy this session, hopefully. All right, just a brief about myself, just given and briefly read by our chairperson just now. So I've joined UTEM somewhere in 2006, and of course before that I was in industries, in HVAC in industries, and the moment I've joined UTEM, then only I think my career started when I first joined in UTEM, because there was a program established by Dato' Abu before this, Professor Dato' Abu. So that program will actually establish for our neighbor over here, our industry neighbor. So IAC during that time. So we are supposed to have a very good collaboration with IAC as well as Malacca government during that time to establish a hub of aerospace in Malacca. So that was the moment when UTEM, thank you so much for sending me to Japan for comprehensive machining aerostructural training in Gifu. And then upon came back, I'm still serving a few industries in nearby Malacca. And then I got an opportunity to go to UK to accompany my wife to study her PhD. And then during that time, I got another opportunity to work with a few companies over there. And then I come back 2013, if I'm not mistaken, somewhere in 2013. Again, serving UTEM, and now beside doing the core business of my duty as a lecturer. So of course, I'm currently also serving other industries in Malaysia, especially in aerospace and automotive industries. So let us just glide through some introduction on what is the CAD-CAM basically. So computer aided design, that is CAD, stand for CAD. All right, normally the CAD now, the industry out there is definitely embed or actually adopt a CAD system in their current daily production. So it's very, very vital and important nowadays. So every single company out there, what we can see over there, almost every industries adopt this kind of system. So the CAD system. And then the CAD system will allow us to do all those design and how to do the validation of the design. And then when it comes to the CAM is computer-aided manufacturing. So this is where my expertise, I would say that my area will comes in. So once we have designed everything in the CAD system, so we need to actually visualize in the CAD system. Then after that, we want to make it a real physical part. That's where the CAM will taking place. So basically, the CAM, computer-aided manufacturing, we actually preparing the toolpath for CNC, computer numerical control. So that is the toolpath that we have prepared in the system. Then we will translate into the controller. So once we post it into the controller, and then the overall machine will actually machine according to the toolpath that we have created in the CAM system. So the CAD and CAM system integrate together in the virtual world before we actually translate or transfer into the real machining world, which is the real part, the physical part, the physical machining part. And then this is a kind of evolution of design tools. So started was in 1970, where people or industries out there using a manual paper drafting before move forward into the 2D and 3D CAD design. All right, and straight away to the 3D general application. And nowadays, I would say that almost every precision industries out there will always, they call it a virtual brainstorming. So every single thing that you have in mind, so you have to translate it into the 3D CAD model. So people will basically easier to others, to the layman, so the rest of the department to understand what are in your mind. So you can actually put everything in the virtual. So that's why the full digital prototypes or 3D system translate into the prototype. All right, these are the so-called the end user of the CAD model. So once you have the design, the CAD model that is already established, so where can we actually post this CAD model or the design? So normally, the most famous in the industry is CNC manufacturing. So that's where I'm currently in right now. So this is my I would say that my field, and of course the rest of the team as well. And then a rapid prototyping. This is part of IR 4.0, Industrial Revolution 4.0, is 3D printing, rapid prototyping. Then we do have automation. We do have design, detail, and form, visualization, and part of it is going to be simulation analysis. Nowadays, if I'm mistaken, the South System, one of the giant of solution provider, they have introduced a new software, a new solution, I would say, which integrated all these functional analysis in the software. So in order to produce a good prototype, you don't have to actually produce or straight away go to the experimental phase. We actually can simulate everything. You can put all those function, for example, like a car. You can put everything, the friction and everything inside there, and the spring function. Then we can simulate inside the software before we actually do the so-called the real analysis or experimental analysis. That's where we can cut a lot of costs, saving before we go for physical testing. All right, so this is the 3D downstream benefit. So we have the CNC manufacturing to manufacture one to another, and then we can do a mass production of this one from the CAD system that we have, the CAM system that we have translated. Besides that, we do have rapid prototyping that I mentioned just now. Based on the design that we have created, we can actually validate the design by using the rapid prototyping. The design detail form, so this is how we can actually put everything based on our design. All the details of the design can be translated to the physical parts from the CAD and CAM system that we have. And last, but I think this is the last simulation and analysis, the one that we have mentioned just now. We can actually do a certain simulation, certain analysis, the stress analysis, for example. We do have other analysis as well. We do have a CFD, computer fluid dynamic, also can be done in the system or in the software right now, before we can actually proceed with the next stage, which is the prototype stage. All right, this is some fundamental, also called basic understanding or knowledge in terms of CNC. So once we do have the CAD system and the CAM system in place, when we have created the toolpath, and then we have to translate and transfer everything into the CNC, or so-called computer numerical control. So based on the machining, so what we have a various type of various configuration in the market right now. So various brand that I can share with you guys later on. So this kind of all those axes involved in the machining. And this is part of the 5-axis machining involved. And we do have all this one as part of UTEM facilities in the shop floor, in our laboratories. And this is also a kind of a variation when people are talking about 5-axis. Nowadays, the design are getting more complex, more sophisticated. If you can see, or we can actually realize the design of the car right now. So it's totally different if you compare for the past of 10 or 20 years ago. So totally different. So the challenge to the manufacturing is definitely very, very high. So that's why we have to have all this kind of recent technology to support the manufacturing processes. All right, this is part of the 5-axis, also called machining centers that are available in the market. We do have, this is the MG Mori, so one of the top player, and Hamler, also from German, so this is also from German. And now the MG Mori is already joint venture with Mori, which 2 different plate of wool. So the south and the west is already combined to actually conquer the wool. Then we do have also quite a famous machine manufacturer out there, which name or known as Mazak. So it's very high and sophisticated machine, if you can see from here. And these are the example of solution provider or software available, which is some of them are really focusing in CAM field rather than CADCAM. All right. So this is these are the one that that we can get in the market out there. So we have CATIA Machining, we have Hypermill, NXCAM, SolidCAM, Power Mill. And as far as UTEM is concerned, we are focusing on CATIA Machining. That will be our first core business or the core subject that we embed in our curriculum. And we do have also Power Mill and Feature Cam, as well as Power Shape in the laboratories, which are available in our laboratories, as well as we embed into our system. All right, these are part of the advantages of having the CADCAM system plus the machining. We can create of complex contour and parts. Simultaneous movement and fit along all 5 axes can actually produce a very complex profile. So we can actually design various kind of design to suit into our final assembly product. So 5 axis allow machining on 5-sided. So this is also part of 5 axis so-called flexibility in machining rather than having 3 axis in the normal market. So we do have 5 axis, which are 5-sided, can be machined at one time. The accuracy of the part definitely will increase. Okay. Right. So this is also an advantage of summary. What we can see over here that with the 5 axis in place, we can actually approach a certain area by only single setup. So we can machine this area, that area, and the other area by actually holding only only single setup. And this is quite famous parts always machined by using 5 axis. We call it turbo machinery turbine blade. So this is also involved in the so-called complex machining and CAD/CAM system. Besides that, we do have also the disadvantage. Of course, is related to the large investment because the machine is not that cheap, as well as the system, the solution system is quite expensive. CATIA itself will cost the company up to more than 100K RM ringgit Malaysia to invest in the first stage. Then they have to actually groom a highly skilled programmer in order to do the program, to create the cutting tool or toolpath program. And finally, of course, the maintenance, how to maintain the machine also will incur a certain cost. So that's why this is part of the advantages of embedding this kind of system. All right. From now on, what I would like to do is I would like to share a little bit on based on the CADCAM and advanced machining system. So some of the example that I have gone through with the industries out there, and then probably we can actually realize that how important that we need to really stand together with the industries out there. So we do have all those facilities in-house. We do have the software also in-house. In fact, we are actually embedded our curriculum with the current demand of the industry, with the current software that they've been using. So definitely we can actually be together with the community as well as the industries out there. So this is just a sharing me myself where I started to jump into this area. So it was a few of us, four of us in Kakamega Difu to go gone through the training for 3 months before we come back to Malaysia. And then this kind of example from the CAD and CAM system, how we translate it into the CNC, and then finally we produce to the actual part. So this is an example of a project that we carried out with CTRM, our neighbor actually. And there are a few projects that we have gone through with CTRM, thank God on that. And then this is the example of so-called validation of composite panel. So they have laminated this composite panel, and then when they want to validate a certain so-called skilled worker, so they need to do some validation on the material. So they have to go through the strength of the material. So probably this is going through the tensile test in the laboratory. So we do have the CAD provided by the company, and then we need to create the toolpath, so-called the CAM system, and finally this CAM system or this toolpath will be translated into the G code and M code, and this one will actually send into the machine before we do the physical machining. This is also part of it. All right, so this picture on the right hand side over here, so this is an example of the real machining taking place, where this machining or this machine is actually following all this coding. So this is what we call ISO CNC coding. By having the CADCAM system, you don't have to actually punch in one to another. So we can actually just create the toolpath, how we're going to do what we want into the toolpath, and the next pass, what is going to do, movement the tool from one to another, what is the type of cutting tool, diameter and everything. You have to define everything over here. Then the system itself will actually translate into the program. So we just put inside the machine and then do the certain setup. But of course, the knowledge, the fundamental knowledge of machining cutting tools and the cutting strategies and everything, we have to do that. We have to have that knowledge before we can go into this phase. So this is part of a project that we have gone through with the CTRM. It's part of aerospace, but this is not a flying part. This is an example part. And then this is another example of validation of the composite material. But before this, it was glass, GFRP, glass fiber reinforced plastic or polymer. And this is another different material, but a very famous material used in aerospace, aerostructural industries. So this is a CFRP, carbon fiber reinforced plastic. So we do have a different cutting tools, and what we did, actually, we just trim into the certain ASTM standard for them to do the validation. All right, this is also another project, which also involve a CAD system. From the CAD system, then we translate into the CAM system. We do have the cutting tool, we do have all the shape that we want to machine. And finally, then we produce the actual part. All right, this is another example. So this, if I'm not mistaken, this was the first trial of wet panel or OOA panel, out of autoclave panel. So the Airbus trying to produce a panel, a composite panel without the curing process of autoclave. So they have successful to produce this kind of panel, and this panel is already being used for A350, if I'm not mistaken. And then this is also an example of the beauty of CAD system from so-called 3D scanner. So part of rapid prototyping or 3D printing. We do have 3D scanning, a 3D scanner. So we use that 3D scanner to scan the geometry of this cutting tool, and we can actually do any measurement from here. We can actually extract all the data, and we can reverse at any time. So this is part of reverse engineering. Also involve CAD system, right? A CAD system. All right, this is also another example, but it's different material. So this is a metallic material, and then this is also part of trial phase, trial progress in our laboratory. So if you can see over here, this is also involve CAD system and translate into the real machining. All right, so this is also a real part, but this is not a flying part. This is an example of fixture or tooling. So this fixture has been need to be so-called produced in order for the CTRM, for example. They're producing the composite restructuring material, so they have to lay out inside on top of this on this tooling or fixture. So we have involved with nearby industries to provide this kind of services. And then this is another example where we are given the CAD model, how to produce this one, not only the knowledge or the skill, how to use the software, but we have to have the skill of how to perform the real machining. So by being an expert in CADCAM software, it's not enough to produce a high precision part. So we need to have, need to have different knowledge and fields in order to produce a certain specification given by drawing. So for example, this is part of the actual flying part from IITC Taiwan. It was produced if I'm not mistaken, a few years ago. So this is part of FAI, first article inspection. So we do have the CAD system over here. The CAM system is not shown over here due to the certain so-called secrecy. But anyway, what we can see from here, how to translate from the virtual to the actual, the CAD and CAM system will actually involve in order to assist us to go through the whole processes in order to get the physical part. And this part is going to be the one that our client or the customers need. And this is the final business of the industries, especially in aerospace industries. All right, this is another example. This is quite a huge part, but this one is is a little bit different. Why? Because of the part is already produced and fabricated by a certain supplier, but there will be, if I'm not mistaken, there were few modifications need to be made in order to suit with the current revision from the drawing. So this one is very challenging because of if we fail to produce or we make any mistake during the machining, so the whole piece will be rejected. So the cost of the whole piece definitely very expensive. So that's why we have to be very, very careful in order to produce based on the specification given. And we have to ensure that there is no any mistake during the machining or during the programming. So this is the CAD system given without the bottom section. Because the important part is this top surface, and what we need to do, we need to skim off this so-called suction area for the composite panel to be placed over here, and then this part, the whole piece, has been placed in the machine, in the CNC machine, and perform the machining operation. And finally, you put inside the CMM. This is part of the CMM operation, which is a coordinate measuring machine to measure the dimension of the newly produced part. So this dimension very critical. So when we have this one comply with the specification given, then only this part is accepted by the client. All right, so this is another example also of flying part. That was the previous example was tooling fixture. So this is the flying part, the actual flying part. So what we can see from the CAD system, we do have the table. So this is the example of actual table is created into the CAD system, into the 3D. And then we do have the fixture or the tooling, and then the flying part or the part to be machined on the top of the whole system. So what we can have over here, we can have the whole system created in 3D model, then embed everything inside one system. And then during the machining, we can actually visualize, simulate whether there will be any collision or not before we can proceed to the actual machining in the CNC machine. And this is the final product that we have produced. All right, this is kind of overall sharing that I can share with everyone on the shop floor. What we have over here. Well, this is a current practice in actual aerospace industries. What we always have during the discussion with the client and during the so-called the bidding process before we secure the project, we always provided the CAD model. So the client always provide the CAD model in order for us to know how, in terms of the difficulty levels of each part that we're going to machine. So based on this CAD model, we need to create so-called cutting planning. So this cutting planning need to, normally it's an experienced person, normally 1 to 2% in one industries. They have been working for more than 10, 15 years. They have more experience in terms of how is the best clamping system in producing this part. So once we have this one and created so-called the virtual cutting planning, then we have this part. This is the CAM section. So we have the CAD system, the CAM section. We put everything, all the cutting tool, all the specification that we need, and finally we try our best to obtain the part more or less to the one that we have planned earlier. So this one will be translated. Okay, this is an example of communication and documentation. So in an established company, they have a very dedicated worker. For example, like programmer is a programmer, and the planner, cutting planning is they do the cutting planning. They do have the programmer to do the program, and the machinist will actually always in front of the machine. They probably look after more than one machines at one time. So they don't actually know what is going to happen from one to another. For example, like one tool to another, which area they're going to machine first, which one is going to cut off first, and the position of the cutting tool, where to go, where to start. So this is kind of documentation that we can, the programmer and the machinist can communicate. So based on this documentation, they should actually know what is the next process to carry it out. So based on this is kind of a physical simulation before we go into the actual machining, and finally we got the part as per plan, as per CAM that we have created. So this is the beauty of CADCAM system and advanced machining. When I first study and when I first involved in this kind of area, I was hardly believe that the part that we have created and we have design over here is going to be resulted exactly based on the CAD system or the CAM that we have produced. But believe it or not, in actual situation, the machine will try to translate everything that we have created here. As far as we do have a very so-called high compatibility machine controller, as well as the the CAM system. So the CADCAM system need to communicate with the controller in the CNC machine with well communication. The compatibility is very important. So that's why if we have that one, then we don't have to worry of producing a part not according to the design that we have produced. So that's why the validation process is very important. And if that post-processor so-called is already validated, and whatever things that we have created or programmed in the CAM system will actually translate it 90 to 95%. Then another 5% variation due to the physics, which actually not considered in the CAM system. But 90-95% will actually translate it into the actual as per design, as per CAM program. All right, this is just a brief, short, probably sharing. So this was last year project, and then this is an actual situation where this is one part number. This part number need to produce at one billet. We call it billet, the raw material. At one time, 3 pieces in one shot. So this is the cutting planning, so-called. So, and this is a CAM. All right. So we do that. A programmer or a CAD-CAM programmer or CAD-CAM engineer, he or she need to be able to produce this one. All right. So he or she need to actually having a certain knowledge on cutting planning. So this is the cutting planning using the CAD system, and then jump into the CAM system to create the CAM toolpath. Once created and then transfer into the machine. If you look at over here, this is not vertical CNC machine. So this is horizontal CNC machine. So this is the material, the raw material given. Now the machine is actually performing the roughing operation, and this was the real raw stock or raw material given, and finally this is the final result. If you look at, if we can see over here, and this is all the clamp placed next to the material, next to the part of the machine, and it's already placed here in actual condition. So if we follow exactly what has been planned in the CAD and CAM system, and we definitely will get the actual part as per design. So it's very important to communicate between the programmer and the machine as well. So the communication is very vital in this case. Otherwise, we're not going to produce the part according to the specification that we have that requested, or probably that already stated by our client. So this is kind of example, a few example. Okay, so this is a drawing from Airbus, from Rolls-Royce. This is a part of engine part, and then this is very, if you can see over here is 1984. It's very long. I would say the old drawing during this time, but we're still using the handwriting or hand drawing of what we can actually see in the previous and the earlier slide just now. And then this is an example of master model. And then if you look at over here, there are a few giants over here in aerospace. And thank God I've been given a chance to involve in this kind of project. And then this is an example of Bombardier. It's quite a recent project, and this is the master model, example of master model before we do the bidding. All right, the rest I would like to share a little bit on the involvement. So probably I would like to invite the rest of my colleagues over here so we can actually contribute back to the industry, because although we are the academia or so-called a lecturer, and we are really needed in industry to collaborate with them, because the academics plus the industries, we definitely can produce a superb result rather than only one-sided. So based on our research, or we might apply whatever things that we have researched in the university with the industry. So this is an example that a few talk a few project carried out with one of the giant manufacturer located in far northern region of Malaysia, ACM, which is located in Bukit Kayu Hitam. There were a few projects. This is part of the training with them. So I've been again the big thank God I've been given an opportunity to share and train some of the experienced programmers, some of the experienced engineers over here, and also involved with them a few projects. So this is quite a, I would say, a massive machine. What we can, I guess this is the biggest CNC machine in Malaysia. So this is a 15-meter composite CNC 5-axis machine. They can actually put a very huge panel, a composite panel over here. And there will be no downtime by using this machine, because this machine can set up during the machining in one side, the setup can be done the other side. So zero downtime for setting up downtime for this machine. So that's why they acquired this company acquired that machine. This is another one. This is for fresh or young engineers to sharing with them by using the CAD system and the CAM system, CATIA V5. This is also a sharing involved with another, I would say that supplier or contractor in aerospace, which is SMA Aerospace, located in Sungai Buloh. They are metallic supplier, if I'm not mistaken, for machining. So all the materials inside here are metallics material. This was, if I'm not mistaken, 2020, during the pandemic. And this was last year. I was together with Encik Madran to involve with one of the so-called project with them. So it's a good experience, and I think this is something that I would say that privilege that we can actually gain. All right, so next I would like to just sharing from the point of view from industries. Some from industries from internally from our laboratories basically. So I'm really proud to share over here with this platform with the team that I currently having. So thank you so much for the rest of without the team, without the teamwork, I don't think that we can actually achieve a very high result. So that's why the team, I would say that teamwork is very important in order to go further, all right, to achieve a certain achievement together. So this is kind of example of internal, I would say that project. So this was, if I'm not mistaken, back in 2015 to 2016, where we were really active in producing FV, Formula Varsity. So we have involved, my team and me, myself, we have involved into the optimization using the finite element analysis. So this is one of the students' project, our final year students' project, to actually optimize this design. If you look at over here, it's really a full material. And then this is already, we got a few holes over here based on the simulation or analysis over here. We can see that the strength, we can maintain or can improve the strength with the less material produced. So once this is validated and then sent into the CAM system, so this is a CAM, CAD and CAM, we produce the so-called the tool path, so how the tool is going to go, and finally we translate it into the so-called NC program and send into the machine. And during this time, I think during this time we don't have the 5-axis yet. So we just produce this part by using 3-axis part. And this so-called knuckle has been produced by using 3-axis machine. And then where this knuckle located, fixed in the 4 different area over here. And then you produce in-house. So this is an example of actual internal project. And the next one I would like to share with every one of my colleagues this afternoon. It's a project of, it's a real project from, basically, I would like to quote this project, is actually brought by RPM Dr. Rizal Kahari. So this is an example of real project that we produced in the lab. It's an actual 16-inch sport rim for, this is not for car basically, so this is for electric motor. It's a project with MIMOS. So what we can see over here, the cap system involved over here, translate into the cam. So this is the cam done already. Partially, I would say that 60-70%, and translated into the machine by using the CNC and C code, G code and M code, and this the roughing operation, the finish of roughing operation, and this is how we fix into the machine. This is part of the probing operation. That will be the clamping preparation. This is a roughing, semi-finish. We do have the semi-finish on the side and both four-sided. And finally, we managed to produce a very clean and I would say that shiny surfaces by using 5-axis machining. And then we flip over the part, and then this is very, very important. If we fail to produce this part, the spoke from the rear side is not matched with the front side. So this material will cost about 4,000 to 5,000 ringgit RM, will actually scrap. So that's why we need to ensure that cutting planning is superb. So that's why we need to plan carefully. Otherwise, this project is not going to be successful. So alhamdulillah, so finally we managed to produce this part. All right, just a little bit sharing on the actual machining. So this is the actual machining taking place, the simultaneous 5-axis. All right, so if you look at, this is a very, I would say a huge material. Right, that is the cutting tool now producing the area of the outer area. Right, so this and the bottom here, what we can see is during the semi-finish process, what we can have, what we can see over here from the top video over here, we can see that is a square material excess. The excess material is this square. The bottom here is already finished, it's already machined. So more or less we have about 60 to 70% completed. On the top video, this is a very important video for us because of this is the moment where I would say that we really waiting for. And this is a very important moment because of once this, the bottom area and the top area, it's already machined. So we can actually, whether the spoke is already match or not. So without the good matching, so this material, as I said just now, is going to be scrapped. So it's not cheap. This material is not cheap. It's about 4,000, 5,000 ringgit. So that's why, yeah, as I said earlier, so the cutting planning, not only the CAD and CAM system, being an expert in CAD and CAM systems is not really sufficient to produce a high precision part. So we need to have all those knowledge like machining, the cutting strategy, cutting tool technology, as well as the cutting planning in order to produce the high precision part like this. And last but not least, this is the actual part out from the machine without the polishing process yet. So this is again, as a result, machine part from the machine without the polishing. So we can see it's very shiny. Okay, so it's kind of satisfaction. Right, so this is a machine, as is Jazimin is the expert of the CNC machine, I mean myself. This is another project that we have gone through before this. We call it a brake caliper project, but with different material. So this is quite a hard material. And then this one also, we gain a lot during this time because the cutting planning, if we fail to do this is the second part that we machine. So the first one was rejected due to the accuracy. So we have to redo and recreate and replan again in order to make sure that the final product match or follow the specification given. So this is, if I'm not mistaken, it's a mild steel hardened material. So it's quite hard, it's quite difficult to machine. All right, with the time that we have, not much. I think just a little bit sharing with you guys. Yeah, probably this a small experience that I have gained in UK. Basically, you can actually boost out every one of us to try to collaborate or try to work with not only in Malaysia, but we have to trust ourselves that we are able or we can actually work with the rest of the industries in the world. So basically, this is the first company that I work with, being a CADCAM programmer. So this is part of the motorsport industries, which is Ford Racing. My job was need to produce the cutting planning. So this is all this fixture. I need to plan all this fixture before, and something it's the biggest challenge over here is most of the part were the casting part. So as what we know, the casting part, the tolerance of this casting part is not the same like what we produce from the billet from the whole block. So that's why it's very challenging to plan the right fixture. So the right fixture to machine this part. So this is kind of just a quick one. All right, this few facilities available. This is one of my best friend, and then this is a picture where I've been into the Birmingham to go into the exhibition. There are many machine manufacturers over there. We can actually learn a lot during the exhibition. Then this is the part again, how to produce a certain area need to be machined. Of course, this part is very expensive, so we need to plan carefully before we send into the machine. And this is another project to redo from the drawing. So this is not related to machining, but again related to the CAD system, how we manipulate the CAD system to produce multiple of parts by using only given drawing. So this part is not provided with the CAD model. So in order to produce a good high accuracy part, we need to have the CAD model. So what I need to do, I need to recreate again this one from scratch from the drawing. This software, if I'm second, this is a Hypermill HyperCAD. This is another company. I got an opportunity to jump into another company. This company is quite closer to the place where I've been living. So this is part of experience working with so-called overseas company. And of course, the experience and the knowledge that we have will actually assist us to ensure that we can survive in this kind of company. So if you look at over here, this is another, my last company that I've been working with, called Benham Manufacturing. And then I was there for 4 to 6 months, not long, but I've been involved with various type of cutting planning and fixturing. So this part of my table over here. So there were few materials over here. What you can see over here is part of the products that we need to plan and do the cutting planning for this. This was my table over there. Then I got an experience to produce a few drawings and a few so-called SOP that they need to follow. And this is part of small experience that I've gained. Right, these are the rest of CAD model that involve And a quick one, I just browse through the slide, just a quick sharing with all of my colleagues today. So this is an example of another project that we did. We successfully managed to machine this part in the lab. All right, this is also quite a challenging project with the Petronas. I would like to quote this project also brought by Dr. Shukri. Okay, so this is very hard material, and alhamdulillah we managed to produce this part as per drawing, as per the requirement from the client. And then if you look at over here, this is from the CAM system, and this is from the simulation of the controller. And finally, this is the actual part. So what we can see over here, the translation of CADCAM system, controller simulation, 99% I would say translated into the actual machine part. So that's why we have to believe into the system, and we have to make use of the system to the maximum level of the flexibility offered by the solution. And this is an kind of example. If I would allow to share this one. All right, so this is part of very slow, I would say, that machining, because this is hard material. We cannot go fast actually. And this is basically the same approach that we have done based on the one that we did in for the spot rim before this. Right. So this is the final one. If you look at over here, so almost there. This is a machining for the central area, and then this is machining for the side cutting or slotting. And then we have the final part now, which is already machined. And then we actually brought the motor to try to do the fitting. So once do the fitting, it's already fit and match based on a certain tolerance that required. Then we put again, put inside the machine and do the final finishing. And this the picture for the final finishing with the complete full assembly. And this an example, the actual example in the real application. So this is called Kangwei Complete project for the it's located somewhere in the if I'm not mistaken, somewhere in the port in Malacca. All right, so the rest an example of application of CADCAM, but various project. I would say this is part of project with UPNM. So UPNM, University Pertahanan. So we have been given an opportunity to produce an example of a missile launcher. So this is also machined by using 5-axis. This is CADCAM system produced in the CADCAM. If you look at over here, so this is the result of CADCAM, the result on the actual, translated almost 95%, I would say. Then this is an example of the beauty of 5-axis simultaneous machining. So all the 5-axis are actually working at one time. Right, so the final result, then based on this, and thank God, based on this result, then we have got another project with UPNM. So this is also quite, for us, it's a high profile project because of we managed to help or assist UPNM to produce a high-end, I would say that souvenir for Yang di Pertuan Agong, Your Highness. And then it's a 2 to 3 weeks project, and the full focus has been given to this project by the top management of UPNM. And finally, we managed to produce to help them producing this souvenir to Yang di Pertuan Agong. So this is their Vice Chancellor presenting the souvenir to our Yang di Pertuan Agong. Okay, I think this is the last one before we end the session. Just again, a sharing from myself. An actual project with Angkatan Tentera Malaysia. It was like last year, end of last year, August, still in PKP or still in our MCO, but we managed to deliver this project by, of course, the support from the faculty, and of course, from our top management. And then it's kind of souvenir, again, kind of souvenir to present to the one of the Panglima, if I'm not mistaken, right? To produce this scrambler. It's quite funny when the first that we heard that they requested a scrambler, but we have challenged ourselves, and finally we managed to produce this souvenir for them, for the ATM. And it's really interesting, I would say, to produce this kind of a complex machining by using the CADCAM and advanced machining system. So this is all the teammate involved. With that, I guess that's all from myself. Thank you for your, I would say that for the time, for PGIM, for giving me the opportunity to share. And I would really hope that with this sharing, we can have a new kind of collaboration, or probably we can have any project, for example, like work together in the future, inshallah. With that, I end my presentation and I pass the session back to Encik Nasri.
Thank you, sir, for the informative information, presentation, and sharing section. So, guys, I'm going to post the link for the attendance today, the chat box. Don't forget to fill in the form. And I open the Q&A session. So, if anyone have any question, can open your mic and just ask the question.
Assalamualaikum.
Assalamualaikum.
I would like to ask, what is the next process that you done? Because I see that after machining, the surface is like leather, like it's not smooth. But how do you make it smooth until it's smooth? That's all.
All right. Thank you, Mr. Akmal, for the question. Okay, in the actual situation, especially in aerospace industries, after the machining, there will be another department. They call it the smoothing department or the finishing department before they move forward into the shipping or the final delivery department. So there are various machining, I would say that part of the machining processes is like a grinding process and so on. So that's why it depends on the requirement. If, let's say, the requirement of the part to be machined, the part to be delivered, it needs to fulfill a certain RE, for example, like surface finish. So there will be another processes involved in order to fulfill that requirement. So again, to answer that question, we have definitely we have another processes involved in order to fulfill the requirement from the client. So it depends on the requirement or the specification given. Is that answering your question?
Yes, Doctor, may I know what is the price for 5-axis CNC machine?
Right.
Big
Okay. 5-axis machining center. It's actually I would say that it's depending on the brand. So if you are looking for like not in the German or European brand, you can actually simply get between 700 to 800 K RM ringgit Malaysia for a medium size of a table. For example, like 450 to 600. It's around that. Yeah, it depends on the brand basically.
Thank you, Doctor.
Thank you.
Hello, Doctor.
So, Amri,
Okay, how you define the cutting parameters for particular products?
all right, thank you, Amri, for the question. So basically, the cutting parameters or the machining parameters, it depends on the material basically and the cutting tool that we've been using. So again, most of the time we've been dealing with metallic material. So basically, it's a certain series of aluminum and certain series of mild steel, and we have a few experience cutting or machining stainless steel. But with the one that I have shared just now, with 5012 pre-hardened material, that will be something that a new experience that we gain. So we are not actually following the so-called formula that we have, right? The VC equal to pi dn divided by 1000. We always go by the range of the material and the cutting tool material. For example, like we do have most of the cutting tool in the shop floor or in the laboratory carbide material. So then we can go a bit faster. So if let's say we don't have a certain dimension, a certain specification of the cutting tool with the carbide material, only available HSS has been stated, then we have to control that fit and speed a little bit tight. So again, to answer your question, it's depending on the material that we've been using or cutting, and as well as the material of the cutting tool.
Okay, one more question, Doctor. Is it any specific toolware standards that you can control the wear, the progression of toolware during the machining? Any specific how you control the wear?
All right. Thank you again, Memory, for the question. So basically, we always go for the so-called fundamental rules of wear. So we don't have any kind of analysis being done during the machining, because the most importantly, we need to produce or to deliver the part as per requirement. So what we always use is a simple, I would say the simple rules. Number one is the sound. If we can actually listen to a certain sound that really trigger that cutting tool is already worn. So we need to change the cutting tool. That's number one. Number two, of course, the physical. We only have a visual check. So based on the visual check, if let's say we cannot produce a certain quality of the surface finish, then we also need to change the cutting tool. So basically, we in producing, I would say that production of precision part, we are not up to the certain where we really monitor the cutting tool. That's why, in order to so-called accepting any job from the industries out there, we need to actually calculate this kind of cost as well. So then only we can produce a good, I would say that a good quotation, and really competitive with others during the final negotiation with the industries out there. Am I answering your question?
Okay, yeah. Thank you, Doctor.
Thank you.
Doctor, when we're talking about force, what do you think the optimum force level that we can accept when machining, in machining?
Okay, thank you. Mr. Akmal again. Okay, for that question, so for our situation, so we are not so-called making money or profit making entity. So we don't have like a cash to actually buy cutting tools, buy material. So most of the time, based on our negotiation with the industries, the material needs to be provided by our final client. What we always request to have one extra material. it's dependent on the project. For example, like the sport rim just now, the material too expensive. So the client can't afford to have a second piece of that material. So we always refer back, or we always calculate back what are the the worst case when do the machining. So the first, I would say, the first level of pricing that we always quoted, of course, the machining time, the programming time, and of course the consumable. So if, let's say, we have the break even of those costing, that's good enough for us to proceed. Is it okay, Chairman? Am I answering the question?
My question is about cost.
Of course, yeah, of course. All right.
Yep.
To determine the cost, or
The force, sorry. Force. Daya.
oh, the force. Okay. I thought cost. Sorry. Okay.
So how you define force?
Mhm.
In order for you to get the best parameter for training in making, you have to see also the force type. And my question is, what is how you define the optimum force for
Okay.
machining some material?
All right. Okay. All right. It's regarding the force, basically. Okay. So as far as I would say that industrial situation is concerned, so we also I've been involved with the research as well. So during producing a parts for the industries, there is no enough time to look into the analysis anymore. So what we always do, we just compensate accordingly. So for example, like cutting force, as long as we do have a few indicator, the first indicator will be the spindle load from the controller. The second, of course, the sound. So we are not really bothered with what is the force currently cutting. As long as we can hear a good sound during the machining, and it's not limited to the certain level of our spindle load, that will be good enough. So we will actually proceed with the machining with the certain cutting parameters. If not, we have to change again. For example, like for certain cases, we do have not only problem occurred during the machining, it's due to the overhang, basically. So to go a very, I would say that deep area, certain area, to reach a certain area. So we have no choice to make the overhang of the cutting tool, it's a bit long. So in that case, we don't have any option. So we have to, I would say that bear with the high cutting force, and then we need to do the finishing on the certain surface that we have machined. As long as the dimension as obtained as per drawing, as per requirement, that will be good enough. In terms of surface finish, we can actually do some touch up and everything. So that's why in producing this, because the time is very limited for us, we are given a certain lead time. So there's no time, or there's no, to do kind of analysis of the cutting force. And as long as the indicator for us is just the cutting, the sound, the cutting sound, as well as the spindle load, the two things that really beneficial for us, or really a good indicator for us to know whether our cutting parameter is now, whether it's okay or not, within the range, within the acceptable range or not. Am I answering the question? Check one.
Thank you.
Okay. So we don't have that cutting force in the dynamometer. That will be more towards the research. Yeah, more towards research. And then, of course, the research, if we have, for example, like Inconel material, it's very new and support alloy that we never cut that before. So we will always refer to the research output from the researcher. So we will look into the range first before we actually expedite the actual cutting parameter. All right.
Thank you very much, Doctor.
Right. Thank you.
Any other question? Okay, thank you for those who asked the question. So before we end our session, I would like to ask to all to open your camera because kita nak step gambar. Also, don't forget to scan the QR code for PGIM FB and LinkedIn. Okay, don't forget to
This will be our next program, which will be held on the 31st May, about on the topics of the value of personalized product design and users' adoption of additive manufacturing and 3D printing, given by TS Dr. Syahibullah Ikhwan bin Abdul Kudus. You can scan also the link provided for registration to get the link for the next program.
Okay, for the session, I would like to ask all to open your camera. 1, 2, 3. Okay, once more. 1, 2, 3. Okay, thank you guys. I hope we can see each other in the next program. Assalamualaikum and have a nice day.
Thank you.
Waalaikumsalam.